Welcome to Ask and Learn.
All right, so if we're trying to form chlorine molecules from chlorine atoms, here's our chlorine atom and then another chlorine atom, and each one of them is going to have 7 valence electrons. So we can imagine that at some point, because the electrons are polarizable and will move around, that they move like this towards 1, 2, 3, 4, 5, 6, 7, towards one side, and then you'll have like a slightly negative, um, and a slightly positive here. This is how, like, I'm basically illustrating London dispersion forces, and then the slightly negative is going to be attracted to the slightly positive, and they're going to come together, and then they'll shift. So like electrons will move to the left hand side of this one and to the left hand side of the other one, so then that one's going to be partially negative, that one's going to be partially positive. So it's not like there's ever like a fixed permanent dipole, like one of the atoms is going to be more heavy on the electrons than the other. It fluctuates, and yeah, you eventually reach a point where you have chlorine, and there's an attraction to the other chlorine, and there's going to be an internuclear distance between the two that's determined, like if this is a nucleus here and that's a nucleus here. It's determined by the trying to lower the potential energy without like getting too close and insignificantly increasing the repulsions from the overlapping atoms, but you want to be close enough so that you can feel the strength of the intermolecular attractions between the two.